Let's discuss the second design attempt for our problem of interactive systems. If you recall from the previous attempt, our main criticism was there was only a single Superman module where the system was very fragile to any changes, even though it's a very tiny change, because we put everything into a single module. And also every label action block that correspond to a single state in our finite state machine is actually very similar in its structure. So that means we got lots of repetitions and duplicates, meaning that we also violates the single choice design principle. So that would be something we'd like to avoid in this second design attempt. So let's see how it looks. But something I'd like to emphasize is, in the previous design attempt, you would do it if you only got assembly language available to you. But now, for the second design, I would say you only use it if you only got a language that's procedural, for example, C, without supporting any OO feature. But if your language really supports OO, you should really use the ultimate solution. But now, let's assume we don't have the OO ability for our design. So let's see how a top-down hierarchical non-OO solution can work. So number one, we want to have a separation of concern. So we want to declare a transition table as a feature of the system, maybe a routine or maybe an attribute. That's up to your implementation. So rather than it's a central control structure, basically we want to separate the concern between transition versus the central control structure. Let's talk about the transition first, and then we talk about the central control a little bit later for this video. So what we want to do is to define a transition, maybe a query, maybe a routine, maybe an attribute. It's up to you. Let's say we have a transition here, and then it simply takes two input parameters, will be the source and also the choice, meaning that where are you currently in the states. And then if you want to make a transition, which choice would you like to make? So depending on exactly the system you're talking about, the range of the states might be different, and also the range of choices you can make from the current state can also be different. And then the return value would just be the integer encoding for the target states. So now we want to think about what kind of contract we can write. You can write some very meaningful contracts. Of course, you want to make sure the source states over here will just be valid. In our particular example for this lecture here, there are only 6 states, so that's why it should be between 1 and 6. And also the valid target state should also be between 1 and 6. And for the choice over here, it's about what transition can you really make between for each state. In that case, we'll simply say it's between 1 and 3. So these upper bounds and lower bounds might change depending when you change your system. Okay, that's something I want to mention. But you can definitely write meaningful contracts there. Okay, so that's about the transition table. And now, how can you implement this? Right? Let's get to a little bit closer to the implementation for your design. So you may implement that using a 2D array. 2D array is definitely the straightforward option to go, or you can have an array of array, an array of linked list, or linked list of linked list, and etc. So let's say this is your transition table, and we discussed this already. And this is closer to how you can implement at the runtime, basically a two-dimensional array. Let me talk a little bit more about how you can manipulate this implementation structure. So we already talked about this is the transition routine or attributes that you would like to support for our new design attempt. And then, so conceptually, this will be your state transition table, which corresponds to your finite state machine. And this will be the implementation as a 2D array. So now let's see how you can manipulate this. So let's say whenever you call this particular transition routine, you call the transition over here, you're going to pass where am I currently. If you say 3, so that means currently you're in state number 3. And then you actually want to go by, you want to go transition by action number 2. So that means you're going for action number 2. And the target state will just be basically just 2. Okay, so this is going to return state number 2. So you can think about this as target states. I don't have the finite state machine diagram over here, but you can verify yourself that if you're in state number 3 and if you try to do action number 2, it's actually going to bring you back to state number 2. Okay, that's something you can verify. And similarly, let's say I want to call transition over here if I'm not in the same source states over here. So now I'm still here. Okay, let's say I'm still here. And now I want to look up and then to see if I perform action number 3. In that case, I'm going to go into a different state. So this means it's going to return 4. Okay, so now if you look at how we are going to manipulate the two-dimensional array, very straightforward. If you say transition over here 3, for example, if you say transition 3 and 2, it's going to go to row number 3 and then column number 2. It's going to give you the same return value over here. And if you go to row number 3 and column number 3, row number 3, column number 3 is going to give you target state return value number 4. Okay, so this is very easy to manipulate. So that's the first aspect for our new design over here, which is about to separate out the transition function of your system into a separate routine. So that's separation of concern. Okay, that's the first part. Let's go back here and then go through some more points over here. So this is definitely a more general solution because now we actually got two aspects for the system. We got either the transition function, which is separate from the central control structure. So now we can talk about these two separately. And then it will be reusable for another interactive system by making changes only to the transition feature. So maybe the central control structure for other system might be more or less the same. So it's very minimum changes you will have to make when you adapt from one system to another, but it's mainly the transition table that you will have to you will actually have to change. But it's quite easy because all you got to do is simply just change the encoding for your two-dimensional table over here. That's all you got to change. So it's definitely a better design for our interactive system. So how does the central control structure look like in this particular design? So that's something we'd like to show you. This is why the design here is called hierarchical. Let's see. Okay, let's talk about this hierarchical solution here. It's also called top-down functional decomposition. Okay, let's see how. So this is the main conceptual diagram you would like to have in your mind to see how the system works. So let me just go over a little bit details over here to tell you how you can understand this. So we talk about different levels. Somehow level 1 is a bottom level, and the level 2 and also level 3. You think about level 3 is where we start the execution. So level 3 is where the execution of the user interaction session starts from. Okay, so we got execution session over here. So execution session is about the interaction session. So interaction session. And think about execute session is not really a Superman module routine. It is not. Instead, it is actually going to call different helper functions to really achieve its goal. So you can think about there are 1, 2, 3, and 4 different helper routines or different 4 different helper functions. We have to figure out what's the initial states. We have to figure out how we can transition from the current state to the next. And also, based on what the current state is, we want to do some state. We want to exhibit some state-specific behavior. And also, we want to check to see whether, after we have done the transition, are we reaching the final states? In which case, the whole interactive section will be terminated, right? Okay, so that will be the second level. You can think about it as a middle level. And then for execute state, specifically this particular helper routine itself also got sub-helper routines, basically. So so execute states also got 1, 2, 3, 4, and 5 different helper subroutines. So we have to display this particular the current states specifically, and also we want to read the input from the user. For example, if you are in a state number 1, in that case, maybe the input to read from the user will be credit card number. If you are in state number 2, maybe the input to be read from the user will be maybe their membership number. So depending on which state you are currently, you may have to perform read differently, right? That's something you want to notice. And also, correct simply means we want to do some validation of the user input, right? And also, since the input you read from the user might be different from state to states, also the validation correction process might be different as well. That's quite natural. Okay, and also the message is really like error messages. In case the validation process actually failed, what kind of error message should we output to the user? For example, for state number 1, you might tell the user your credit card number is invalid. And for state number 2, the message could be, you tell the user your membership number has expired already, right? And finally, the process will be whatever the information the user supply, which might be different from state to state, you're also going to process the information, either to process their credit card number for the payments, or you're going to process their membership number for accumulating their points, right? So you can see the idea here. Well, for the bottom level over here, for all the helper routine, their behavior really different depending on which state you are currently. That's the main point you want to keep in mind. Okay, so also the is final is really about whether we are reaching the final states. So that's the overall picture for the system control. So hopefully you're getting the intuition. Let's now dive deeper to see how the execute session works and how it calls the next level as a subroutine, execute states. So we'll see how the execute state works and also how it calls its subroutine over here as a helper display. And then once we see the patterns in more detail, we can actually criticize on the second design attempt. So let's go back to the slides. Okay, so that's the diagram we just spoke about, and then a general remark. So the modules for execute session over here, how the user interacts with the system over here, execute session, and also how the execute state works, how the individual state is actually executed. So these two modules or routines are very general, which means they are reusable. Okay, that's the plus for this particular design. However, they might also suffer from some disadvantages, as we'll see later. Okay, so let's see for the system control. First of all, let's see this level over here. We want to see the execute session. So all the interactive sessions share the following control pattern. So when we say sharing the following control pattern, so that means this pattern here may be reusable. So it will start with some initial states, okay, and then we have to repeatedly make state transitions, and based on the choices that's read from the user. So the user has to say where they want to go for the next navigation, until the state is actually final. So once the user reaches final state, let's say they have already paid for their confirmation, in that case they can exit from the interaction. Okay, let's see the execute session here. So that's the top level. So you will declare some current states over here. So current state is simply an integer, and also the choice that user might actually enter to the system. So again, we run a loop to say once we start the current state being the initial state. We need to have a starting point, and the starting point is the absolute initial state for the state diagram. And also we are going to exit as soon as we actually reach the current state being the final. So it's final here. You can think about it just on helper routine to help us decide whether the current state is actually the final state to actually exit. Okay, and what about each iteration? First of all, we have to read the choice actually from the user, and at the same time, we're also going to call the execute states routine. So the execute state is going to say, depending on what the current state is, we're going to do something specific to the current states. So we're going to look at the current states in detail in the next part. And also the current state, so now let's say once we are done with the current state execution, we're going to make a transition. So the transition here is calling the table that we spoke about previously, what the current state is and also what the choice is. And once you get the return value from the transition function, you're going to store and update the current state. So that's a very straightforward interaction pattern we have over here. Let me just emphasize a few points over here. Okay. So what we have just spoken about is this particular execute session. I want you to be very sensitive to how we pass the data over here. So over here, you can see when we say it's final over here, so depending on what the current state is, we want to know whether the current state is really final, meaning that we want to know whether we should really exit right now. So when the execute session here is really calling the is final, it's actually calling that with the current states. So the current state is really being passed as input to is final. Not just that, when you are trying to call the execute states over here, what you're doing is you're also passing the value for the current states. So when when the execute session part of it is calling this execute states helper routine, you're also passing current state, the same value over here, right? The current states. Okay, finally, also when you're calling the transition function over here, you're also passing the current states as part of the input arguments. So when you're calling transition over here, you're also passing the current states. You can see the same value current states is really being passed to the next level, like a lower level, to the transition, to the execute states, and also to its final. So we are really passing the data around. Is that really a good practice? We'll discuss that in a moment. Okay, so that's about the execute section you have to know about. So study the pattern, especially about this particular exit condition over here, to understand why this loop might simply just run indefinitely if the user never reaches the final states. And then for every iteration, you're simply just going to mainly call the execute states and also make a transition, so you can keep on going. All right, so let's now talk about the next level, which will be the execute state. So this will be the interesting part to actually look at. Okay, let's take a look. Okay, let's go to the next slides. So now, how do we handle the state, to execute the states? So the following control pattern handles all the state. Again, this pattern of handling the states is going to be reusable for every state, right? So let's say we call it execute states, and then remember we're simply passing the current states over here, right? The argument value here to the current, to the execute states, right? That's why it has a single parameter current state. Just remember that. So now we want to know, depending on what the current state is, we're going to exhibit some state-specific information. Maybe one state requires the credit card information. Maybe another state requires the membership number from the user. So it really depends. So now you're going to see that for the definition for execute state, you will see there also exist lots of helper routines which also require what the current state value is. So that's exactly what you saw before. Over here, you can see for the display, for the read, for the correct, for the message, and process. So these are all the helper routines for execute state. All of them will need to know what the current state is. So that's something you will see. Okay, so let's say we got a local variable here. We got the answer. We got whether the answer is valid, it's a Boolean, and also what the choice this user has made. So we use a from until loop. You can feel free to convert that into the while loop by just negating the exit condition into the state condition if you wish. So now we're saying that as soon as the answer from the user is valid, we're going to exit from execute the states. Okay, so now we're going to display the current states. We're going to read the answer from the current. Well, depending on what the current state is, we're going to read different answer from the user. It could be credit card number, it can be membership number, it can be departure dates, etc. And also we're going to depending on the current states, we're also going to read the choice this user wants in order to make a transition. And also we're also going to validate the user. Let's say the user actually give us some answer, for the current state. In that case, maybe they give us the credit card number. In that case, the correct should really try to validate the credit card number. Let's say if the current state is actually, let's say maybe to accumulate their points for the membership, in that case, the answer might just be their membership number. In that case, the correct validation helper routine should really do something differently. And then we say if the answer is simply not valid, in that case, we're going to print out different messages. Again, you can see depending on what the current state is, we're also going to do something differently. Okay. So now let's go back to some illustration over here. So now what we have just discussed was this fragment of code. I talked about it already, but let me just remark very quickly. So this execute state over here basically got 1, 2, 3, 4, and 5 different subroutines that we have to execute. But for each one of them to really work, they need to know what the current state is, right? So for example, the execute state is actually going to call the display over here, and then we need to pass the current state. Oh, by the way, remember the execute session already passed the current state value to here, but now we are simply just passing this current state value verbatim into display. Not only that, we also pass the current state to the read, and also pass the current state to the correct, and also pass the current states to the message, and also we pass the current state to the process. The same value called the current states is really passing from this level here to this level here, and then to every subroutine at the bottom level. So that's something I would like you to note. Is that a good style? It does not seem to be a good style. So that means somehow your data is simply just passing around. Would it be not possible to make maybe the data itself a separate module? So that's the ultimate design solution we would like to have. But I just want to preview a little bit. Okay, so that's about this particular level here. Before we move on, you really should really get yourself familiar with this particular structure over here. Talk about the different subroutines we are calling for this execute states, and then think to yourself, why passing the current states over here as the parameter at this level? Why would it not be a good style to have? What design principle are we going to violate? Think about it. Okay. So let's now move back to the slides. So now just a little bit more description about if you're wondering about what each individual subroutine should do. Let me just go over a few. For example, display. The display is going to take the current states, display the screen output associated with the current state S. And also you may want to read the user input for answers associated with state S. You can see for every subroutine, we always want to say their behavior really depends on the current state CS or with the current state S. Okay, so that's a critical point. So now, how similar are the code structures of the above state dependence commands or queries? For example, if you think about the display over here and versus the read answer over here, I know that they have very different functionalities. However, their control structure, would they look very similar? So that's my question. Would they or would they not?